Okay, so now we're ready to start wiring the two strain gauges. We're going to take, this is a 3-conductor 30 gauge vinyl insulated wire. The nice thing about this one, it's already been at least partially stripped for us. So Ben's just going to pull off the extra insulation, and now he's going to separate the strands from the red conductor from the strands from the black and the white. So you can use a dental pick, you can use a pair of tweezers, and just chase down along the strands from the red conductor and pull them out to the side. And then he's got the black and the white, so he's gonna twist the black and the white together, but you're also going to twist the 7 strands from the red conductor so they stay tight together. And then on the other end of the wire, he's going to separate each one of the conductors, because we'll have 3 connections at our instrument. So on what we call the gauge end, the black and the white get common together. On the other end, which we'll call the instrument end, each one of those conductors are separated. So same thing, just pull off the vinyl. And then you can use tweezers or a dental pick for this, but separate the strands from the red conductor, pull them out, and then separate the strands from the black conductor, pull them out to the side. And now twist each one of those. Now once we have them twisted, we're also going to tin these conductors, because we want them to act, rather than like 7 individual strands, we want it to act like one conductor. So we'll do that by tinning them with solder, and Ben will show you that in just a minute. But twist each one tightly, twist them tightly all the way down to the insulation. All right, and once he has that, then he's going to take a soldering pencil, bring it over, and we're going to lay the soldering pencil out in front, and then add a little bit of solder to the tip of the pencil, and just lay the pencil out in front of you. It's easier, I find, if you lay the pencil down and let it be stationary and hold the wire in one hand and the solder in the other. And you notice how he continues to feed more solder, because really you need to flux at this point. He's going to do both ends, both the gauge end and the instrument end. And since he's got 2 strain gauges, he's got a second piece of wire that's already twisted, ready to be tinned, laying to the side as well. Yep. So now he's got that one done. Now he'll work on the second piece of wire that's already prepped and ready to go. other than the tinning. All right, once he's got both ends, now you can take the wire, lay it to the side, move the soldering pencil out of the way, put it back in the holster, retin it. You always want to keep a little bit of solder on the tip of the pencil to keep the tip from oxidizing. Now we can go to the strain gauge. So we've got the wires prepped and ready. Now we need to get the strain gauge ready, and we're going to, and by saying that, what we mean is we're going to tin the tabs of the strain gauge. So it's like we're pre-applying some solder onto the strain gauges before we bring the wire over. So this is where we're going to take soldering pencil, clean it, put some fresh solder on it, and now we're going to take the solder, lay it right over top of the tab, and press the iron through and continue to feed a little bit of solder and get the tabs to, and press down firm, count 1, count 2, usually about 2 counts is about as much as you need in order to get these to tin. And if you put it on there and you get a little too much, you can just wipe it off. Just press down firm, count 1, count 2, and then lift them both up at the same time. And it takes a little bit of practice to do this. All right, so once both sets of tabs are tinned, now we're ready to find our lead wire. We've got 2 sections of it that are prepped, and we're going to take the end of it that we're going to call the gauge in and compare it to the tabs of the strain gauge. And what we're trying to decide is how much of that exposed conductor to trim off. And basically at this point we're going to trim off the vast majority of it. We're going to leave about 1/16 of an inch of the exposed conductor left. And we're going to do 2 things here. We're going to cut it short, minimizing our chance of it providing a path to ground. And the second thing that we're going to do is we're going to just nick the insulation between the red and the white conductor, just in case we need a little bit of extra positioning. And also, quite frankly, if you had accidentally shorted between those two, you would have just cut the short. Now, at this point, we need a method to be able to hold the wire in place. So what we're going to do is we're going to use some paper drafting tape. So Ben's going to find a piece of paper drafting tape that's maybe about 1.5 inches long. And he's going to put it right up next to the edge of the vinyl. And he's also starting to put a little bit of a curve in that wire, because what will happen is we're basically going to tape this wire down in place. And if you put a little bit of curve in it, and when you mash it flat, that will help to put a little bit of downward force over top of the tabs of the gauge. So just watch what he does here. It's got a little bit of a curve in it. Then he'll take it, press it down into place. Move the wires around a little bit, get them right over top of those solder connections. And once you're happy with that positioning, now you're ready to reflow the solder at the tabs. Being mindful, of course, these tabs are on the smaller side, and we've got some smaller size wires, so sometimes working under a microscope at this point really can be useful. We're going to give it a go here without the microscope and without any magnification. And just take the the solder, lay it right over top of the target, press through, and really it just needs that heat to flow these two things together. Once you get it on one side, then go to the other side. Excellent, nicely done. And once we get the gauge on the right side, we're just going to leave the tape on it at this point. Then we'll go to work with the gauge on the left side. Same thing, we're going to trim the exposed conductor, cut them back short. Nick the insulation between the red and the white conductor. Another piece of that paper drafting tape. We'll remove this in a few minutes, but right now that's just another piece of that paper drafting tape to help hold it down in place. Tweezers can help you to make sure it's in the right spot. Once you're happy with it, same thing as before. Now it's time to reflow it. You'll need your solder clean. I always like to start with a clean soldering tip. So clean it off and re-tin it. Get a fresh little bit of solder on the tip of it. And then same thing before. And again, these are pretty small, but just take the solder, lay it right over top of the target. Press the iron through. Should be very quick. All right. Once you've done that, you can take the solder, lay it back over to the side, put the soldering pencil back in the holster. Make sure you keep some solder on the tip of that pencil. At this point, we're ready to clean things up and add some protective coating. So the next step is now to clean it, and we're going to use the M-Line rosin solvent. The rosin solvent's a 50-50 mixture of isopropyl alcohol and toluene. We're going to take that, just kind of flood it over top of the solder connections and flood it over top of the pieces of tape. We're going to use that to help us get these pieces of tape off. In and around the solder connections, over top of the piece of tape. You can just, once you let it sit there for a minute, then you can take your pointed tweezers and just kind of help nudge the tape, and it should come right off. This solvent will break down the mastic. Should be pretty easy to get that off. And then go ahead and take off that other piece of tape as well. All right, and once you get both pieces of tape off, now we're going to flood over top of the strain gauges, in and around those solder connections, keep it nice and wet with a rosin solvent, and then blot it dry with a gauze pad. What we're trying to do here is get any of the residual flux off of it. Flux is your friend while you're soldering, your enemy as soon as you're done. So you're trying to get rid of that. So we dissolve it into suspension with the rosin solvent, and then we blot it dry and remove it. So the last thing you want to do is dissolve it and then leave it in place. So here we get it wet, and while it's wet, we take a gauze pad and blot it dry. And go through another washing of that. You want to wash it at least twice with the rosin solvent. So just repeat that process again. and then blot it dry using a gauze pad. All right, once we've done that, we're almost ready to start testing. Two things we have left to do. Number one is to create a strain relief loop, and number two is to add some environmental coating. So we like to use either the handle end of a cotton tip applicator like Ben is showing, or you can use like the handle end of a dental pick. And what we like to do is take the cotton tip applicator, gently slide it up underneath the wire, take a pair of tweezers, start at the gauge side, and rock toward the free end of the wire with the tweezers to put a little bump in the wire. He's going to go ahead and do that for both of them. So press down on that tab side, rock it over, make that little inchworm. Looks like a little inchworm. And then another piece of tape, we'll use that to put the wires and kind of tape them down in place. You could use a bigger piece of tape if you want to. That one's pretty small. It's up to you. Once you have that in place, now we're ready to go ahead and put on the environmental coating. And for this exercise, we're going to use a product, we call it M-Coat A. And M-Coat A is a polyurethane protective coating. It's solvent thinned. It's real easy to apply. It comes with a bottle that has a brush cap applicator. This particular bottle still has the shipping seal on it, so we'll need to get that totally removed. Sometimes it's easier if you take a scalpel or a dental pick to nick it, and then you can remove it. And then we're going to apply this over top of the strain gauges, over top of the wires, down to the piece of tape, and just try to stay off the free end of the beam. That's what we're going to fasten onto the side of the table to test it. So we're going to apply the protective coating over top of the gauges. Keep in mind, as you put the coating on, you want to cover the gauges and the wire, but you also want to cover the flow out of the adhesive. So that usually drives the area that you coat with the protective coating, is how much your adhesive has flowed out. And if that's a problem, then you need to mask it to make it smaller. So you just take this material, you apply it. I sort of look at it like mopping. You kind of take it, put some on there. It's a lot of solvent in it, so a lot of that solvent's going to evaporate. But you can take this and brush it on, and after about 20 minutes, it's going to start to solidify to a point where you could start to handle it. So once you put on the M-Coat A, you want to let it sit for at least about 20 minutes, and then you're basically ready to start handling and start testing. Okay, so we have wrapped up the installation of the 350 ohm and the 5000 ohm C5K series gauge. As you've seen, the process is really the same. The handling of the gauge, these two gauges is very similar. Ben did a great job on lead wire prep, on the installation of the gauges. They look great from an optical inspection. Of course, the next step is to check it electrically, and we'll do that in a later video. Solder connections look really good. So at this point, we're basically ready to start testing. So what I'd like for you to take away from this is that if you do consider transitioning to 5000 ohm strain gauges, the installation of the strain gauge is really the same. We're going to compare these two and show you some technical differences later about how a 350 responds versus a 5000, and you can use that technical information to help you in determining if you want to transition to a 5000 ohm strain gauge. So on behalf of Ben and myself, we want to say thank you for spending the time to go through this installation with us. If you'd like to find out more about 5000 ohm strain gauges or strain gauges in general, please feel free to reach out to us at www.micro-measurements.com, or pick up the phone and dial 919-365-3800 and follow the prompts to applications engineering, and Ben or myself or one of the other applications engineers would be happy to answer any questions that you might have. Thank you.